Okay, we're in advanced math, trig, mod 7. Today is Monday, April 20th. Hope you had a great weekend. We're back at things here. If you remember back on Friday, we introduced you to what were called exponential functions. Most of you did great on that. It's pretty easy, I think, or I thought, to follow along with solving a function that had a missing exponent in it. The reason we started the chapter or unit off with exponential functions is the entire unit is based on all the different things you can do with exponents, and that preps you for the big topic of the unit, which of course is logarithms. So a real easy day today, I think. It's an introduction to logarithms. So again, get out your papers. If you're taking class and notes, pay attention, think with me. If you don't understand the basics that I'm going to go over today, you're going to be in trouble. If you understand these, it's an easy chapter. If you don't listen and pay attention today, you're going to fall behind and get in trouble. So, top left corner, 4/20/20, Monday the 20th. The title is Logarithms. And up in the margin of your paper, by the title Logarithms, I want you to write in quotes the name of your new best friend, which is Ben. Write the name Ben, B-E-N. Now, obviously, Ben is really not your best friend, but it is mathematically right now. Ben stands for three words, right? It's an acronym that stands for base, exponent, number. Base, exponent, number. All logarithms are is taking some base, raising it to some exponent, and when you take a base and raise it to an exponent, you end up with a final number for an answer. With that in mind, everybody start out by just writing the word log and then do the following. Okay, guys, ready? Every single time you see the word log in the next 6 days, down below the word log is always located the base of your exponential problem. So every log has a base. On the other side of the equal sign is your exponent. And when you take a base and raise it to that exponent, you end up with some final number. So ready? Follow the bouncing pen. Train your brain to think this way. Every time you see the word log in a math problem, I've got a base raised to an exponent, and if you take a base and raise it to that exponent, it's going to give you some number at the end. Ready? Base, exponent, final number. Ready? Base, exponent, final number, Ben. So, with that in mind, we're going to do 3 logarithm problems where you're solving or filling in the missing blank without a calculator. No calculator is going to be touched on 90% of the problems today. Guys, when it says log 2 8, you can't pull out your calculator and type log 2 8. That button doesn't exist. You see the word log, your job is to very calmly use common sense, use your formula Ben, and try to figure out the missing blank. Now, I'm going to warn you right now, 90% of the kids, when they see this problem, they think the missing blank is a 4, right? Because for some reason, their brain says, 2 times 4 gives me 8. That's not how this works. Remember, 2 is my base, the blank is my exponent, and 8 is my final number. So guys, do you agree when you see this problem, this is how you have to train your brain? I have a base of 2, an exponent of I don't know, and a final number of 8. So it's really asking you 2 raised to what power gives you 8? Have you thought about it? Isn't the answer 3? 2 to the third power is 8? Because think about it. 2 times 2 times 2, right? 2 to the third power, gives me 8. So that's the general idea. Now, you do have to be careful. Look at the second one. 3 log base 3 of 1/9 equals blank. Okay, it says log, doesn't it? Every time I see the word log, I've got a base of 3, an exponent of I don't know, and a final number of 1/9. I'm going to give you a second. What would that missing exponent be? Okay, now careful. Isn't the key number here the 9? If that said log 3, 9 equals blank, isn't 3 to the second power 9, right? 3 squared would give you 9. But since that 9 was flipped over and it says 1/9, remember the rule that negative exponents get flipped over. So the only way 3 can turn into a 1/9 is if you raise it to the negative second power. 3 to the negative second is 1/9. Because, guys, pretend the negative's not there. 3 squared gives me what? 9. But because it's a negative exponent, I flip that answer over and get 1/9. Okay, so careful. And finally, this one here, a little bit tricky. I have the word log, so I'm thinking base, exponent, final number. My base is 49. My exponent is I don't know, but I want to end up with 7. What would I do to 49 to turn it into a 7? Okay, do you agree here? Wouldn't I square root it? Wouldn't you square root 49 to have it turn into a 7? Guys, a square root box is really a power of 1/2. I'm going to say it again. A square root box is really a 1/2 power for an exponent, okay? So 49 to the 1/2 power gives you a final number of 7. So those are the 3 little things you got to watch for when you do basic logarithmic calculations, okay? All right, now, okay, continuing with your notes, the next 3 problems, the blank is on the left side this time. Well, so what? Let's think our way through these. Okay, ready? Says log, doesn't it? Good news. Every time it says log, no matter which spot the blank is in, my brain is still thinking Ben, right? I have a base, an exponent, and in this case, I'm looking for what? My final number. So actually, this is the easiest or most straightforward kind of logarithm problem. If my base is 5 and my exponent is 3, so I'm thinking 5 to the 3rd power equals, I'm looking for my final number. Now careful, please don't write 15. 5 to the 3rd means what? 5 times another 5, which of course is 125. Over here says logarithm. So I have a base, an exponent, and a number. My base is 4. My exponent is -3, so we're seeking our final number, aren't we? Guys, I'll say it again. A negative exponent does not produce a negative answer. Pretend the negative's not there. If I said, what's 4 to the 3rd power? If that just said, what's 4 to the 3rd power? That means 4 times 4 times 4, which would be 64, wouldn't it? But because it's a negative power, that answer gets flipped over. You got to put 1/64 in the blank. Be careful. And then down here, again, a little bit of a tricky situation. Says log. So I have a base of 8. I have an exponent of 1/3, and I'm looking for my final number. Agreed? My base is 8. My exponent's 1/3. I'm looking for my final number. Guys, remember up here I said to you, a 1/2 power is really a square root box? Well, think about it. If that's a 1/3 power, it's probably a Q root box. Agreed? A 1/2 power is a square root box. A 1/3 power is a cube root box. So 8 to the 1/3 really means the cube root of 8. And the cube root of 8 is what? 2. right? Because remember, what does that mean, the cube root of 8? It means what number could I multiply 3 times in a row to get the 8 that's in there? So the cube root of 8 would indeed be 2. Okay? Finally, now, the last thing on the front of my paper. Oh, if you look at our 3 problems, we got a missing base on all 3 of them. So here we go. It says log. My brain is thinking, what base would I raise to the 3rd power to end up with 125? So what number could I cube? Multiply 3 times in a row to get 125. Do you agree the answer would be 5? Here, what number would I raise to the negative 2nd power to get 149th? Pretty obvious, wouldn't that be a 7 for the missing base? Because 7 squared is 49. Since it's 7 to the negative 2nd, I'd flip it and get 149th. And then finally, what number would I raise to the 1/2 power? Well, I've already said to you, a 1/2 power is really a, what? A square root box? So really we're thinking the square root of what number would give me 1? Oh, well, careful, don't put 2 in there. Isn't the square root of 1 gonna be 1? So my missing base was 1, because 1 to the 1/2 power gives you 1. When I square root the number 1, I get 1. So that was my missing base. Okay? All right, a couple more things to keep in mind as we move forward. Those were just, quote, regular logarithms. There's 2 other kinds we have to mention. First question, put a big star and write, what is a common log? Oh, a common log is a log with a base of 10, exclamation point. It's a logarithm with a base of 10. That's the log button that's on your calculator. If you look on your calculator, there is an LOG, a log button, and that log button is understood to have a base of 10. So if you ever see the word log and you don't have a base written underneath, it's understood to be a 10. It's a common logarithm. So when I say the log of 100 equals blank, and you're supposed to fill that blank in, sure, I could pick up a calculator and type log 100 and hit enter. Or just think of it this way, you don't see a base. If you don't see a base, it's understood to be a 10. 10 raised to what power gives you 100? Wouldn't it be 2? Oh, that's all we're doing here. A common log is a base of 10. The second question in this section, once again, I have a base understood to be a 10. 10 raised to what exponent gives me, now I know it says 0.001. Guys, think back to 7th grade math when you did decimal places. If you counted your decimal places on this problem, isn't it tenths, hundredths, thousandths? So 0.001 is really 1/1000th. Oh, so 10 raised to what power gives you 1,000? Wouldn't that be 10 to the 3rd? 10 times 10 times 10? But since it's flipped over, my answer is -3. Just some logical thinking involved in logarithms. And finally, when the blank is on the left side here, I don't see a base, so it's understood to be a 10. Oh, so I have base, exponent, final number, 10 to the 4th power, 10 times 10 times 10 times 10, actually gives me a value, agreed, of 10,000 for that. Note, if I said, what's the log of 47? There's no way you can do that in your head, because think about it, my base is understood to be a 10, isn't it? 10 raised to the 1st power would be 10. 10 to the 2nd power would be 100. So this answer's got to be somewhere between 1 and 2, and the only way to get it, of course, is to use the good old log button on your calculator. So pulling out your calculator, log 47, I'm literally typing log 47, hitting enter, and I'm getting 1.672. Yes, we'll establish that rule right now. Any log equation, expression, or simplification problem, when you're dealing with logs, we go to the nearest 3 places. Okay? All right, our last question of the day. We've got good old regular logarithms that were on the front of our paper. We just discussed a common log, which was a base of 10. The last question of the day, put a star on your paper and write, what is a natural log? Oh, natural logarithms are LNs on your calculator. If you look at your calculator, you do have a button that says LN. That means a logarithm that's natural. And a natural log has a base of, and it's the letter E. E is kind of like the pi symbol. Remember the pi symbol when you first learned what pi was? It was 3.14 blah, 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 an irrational number. When you see the letter E, which is an exponential expression, okay, E is really 2.718, blah, 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 an irrational number that goes forever. Okay, so just like pi was 3.14 dot, 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 E is 2.718 dot, 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 and is the base of what's called a natural logarithm, an LN problem. So you're going to definitely need calculators here. You cannot do these in your head except for the last 2. That's why they're there. It says ln of 8 equals blank. The natural log of 8 is... If you tried to do this in your head, remember my base is understood to be an E? E raised to what power would give you 8? Well, since E is an irrational number that goes forever, you don't know what power you would raise it to get 8, do you? You literally type ln 8, hit enter, and get 2.079. ln 52. Once again, I turn to my calculator. ln 52 is, and we get 3.951. ln of 1, stop. You can do this one in your head. Think about it. If you ever see ln 1 on your paper, my base is understood to be an E because it's a natural log. It's an ln. Guys, use the Venn formula. E raised to what exponent would give you 1? Isn't the rule from math that you've worked with for a couple of years, if you ever have any base and you raise it to the what? 0 power, anything raised to the 0 power always gives you 1. So the ln of 1 is going to be 0. And finally, if you ever see ln of E and I say, what's that equal to? Okay, I'll give you a second. Think about it. What would you put in this blank if you had to without a calculator? All right, think. Every time you see ln, your base is understood to be an E. So E raised to what exponent would give you a final answer of E? Well, obviously, if you take E and raise it to the first power, you get E. So guys, if you ever see in the course of doing an equation, ln of E, it's always equal to the number 1, okay? All right, that's a good introduction to logarithms. I hope you were paying attention. I hope that makes sense. Your assignment for tomorrow. So since today is Monday the 20th, this is due, I hope you can just do it right now. This is all fresh in your brain. You just watch the video, you listen to the explanation. Your job is to try these 10 problems right here. This is like a 10-question quiz. You're doing your own work. You do not take a picture of your work and send it to your friend on your phone and have them write down the answers as their own. That's called cheating. That's dishonest. We're here for you to see if you can think your way through and understand the problems. Please, guys, I'm counting on you. Do your own work. Every one of these, you're going to see the word log. All you're doing is filling in the blank. 3 raised to what exponent would give you 81? Okay? 6 raised to what exponent gives you 136? Train your brain to think of the name Ben. You have a base, an exponent, and a final number. You should be able to zip through here. This is a 10-point assignment. You get 1 point for every question that you successfully get right. It's that simple. I would hit pause, take a look at these 10 questions, and those are all due for tomorrow. I'll leave them on the screen here another few seconds, but basically if you pause your screen, your video, you can see these 10 questions, copy them down, and send me a picture when you get them done, and we'll kind of go from there. At least now you're introduced to basic logarithms, okay? Whew, great job. I'll see you tomorrow.